Alright, so I'm going to go over the stuff I've been doing. It's not exactly where I want it to be, depending on when I have to bounce. Maybe I'll get it there, but it's good enough to show you guys. So basically, this is like going to talk about the way for us to run and deploy code. I don't have the Reticulum stuff working quite yet completely, but I do have Janus kind of at the point where that service runs. The only piece missing right now is just building Marshall's plugin, but everything else seems to work. And I think generally that the patterns I do for Janus will map just exactly onto the Reticulum stuff, so it's not going to be like a lot of new thinking. I feel like you guys should be able to get Reticulum working if you look at Janus as an example. So so basically the methodology for some of these things is a little bit different than our last project. So I'll talk about the tools that we're using. So obviously we're on AWS. Okay, so basically we're on AWS, no change there. On AWS, we're using all the kind of usual tools, Route 53 for DNS. We're going to use RDS for the database. We're going to use, we're using the VPC for the networking, IAM for permissions. We're using auto scaling groups. That's part of EC2 basically. What we're not using explicitly are AWS specific services like SQS or DynamoDB or CloudFormation or Amazon Container Service or any of these things that would be quite difficult to migrate off of. All of these things are pretty generic tools that could be migrated off of in theory. And then for setting this up, previously, I set this up manually, and then I started using Ansible to set up Amazon resources. The tool we're using now is called Terraform, and that's now a pretty well baked piece of technology by HashiCorp, and that's also being used in combination with a tool called TerraGrunt, which is basically just like a layer of tooling on top of the Terraform command line tools that basically allow you to lay down this configuration in a way that's dry and allows you to deal with it in a kind of what's considered to be best practice setup now. So Terraform Up and Running was the book that I started to read, and generally TerraGrunt is a manifestation of tools that allow you to implement the patterns in that book better. So that's setting up that. The responsibility of Terraform is to basically capture all of our AWS configuration about everything. We never will manually edit AWS stuff via the console. The console should be basically considered a read-only user interface. And so the entire state of everything is captured in Terraform files. And the job of Terraform is to basically take the files you write, cross-check it with the information in Amazon, and apply changes to Amazon based upon changes from your files. So the next piece that we're using is Packer. This is also a HashiCorp. I'll say this is for provisioning AWS resources. And then Packer is basically used for building AWS EC2 images. So the idea here is that instead of using a generic AMI for all of our machines that has no pre-existing dependencies installed or any initial configuration, we're going to be using Packer to build a probably small number of customized AMIs. Right now there are two. One is a very generic base image, and then the other one is AMI that's used for running Habitat services. So it has Habitat installed. It's set up to run Habitat's supervisor on boot and all that kind of stuff. So basically, so right now we have two AMIs. One is a generic one for the Bastion host, and the Bastion host I'll talk about, and then the other one is Bootstrap AMI for Habitat services. Includes Habitat, starts supervisor, discovers peers, on the ring, etc. So basically, if you were to boot one of these Habitat AMIs, it'll actually automatically discover the rest of the Habitat nodes that run the AMI and join their supervisor ring. So we don't have to worry about that. That all is taken care of generically in the AMI. What we're not doing, however, is at least right now, I'm not generating an AMI for each particular service we want to run. So we're not going to have a reticulum AMI because the reticulum, those bits are actually managed by Habitat itself. So setting up reticulum, setting up Janus reduces onto the problem of when the node boots this AMI, it needs to install the packages through Habitat for those services and start running them. But to bootstrap Habitat itself, we do that via this AMI. And so Packer basically is a really simple tool that you provide a JSON definition of the metadata about the AMI you'd like to create, and then also a series of provisioning steps. Basically, they're just shell scripts that will run before it exports the AMI. And then in one command, it'll basically boot an EC2 node, generate a temporary SSH key and a temporary security group for it to be SSH'd into, remotely run your commands via SSH, and then export the AMI and terminate the instance. So it just makes it super easy to, you just run a command and then, maybe 2 or 3 minutes later, it spits an AMI out.
What is the interface between Terraform and Packer?
So basically, Terraform defines our auto-scaling groups, and auto-scaling groups are an abstraction in AWS to basically manage a group of EC2 instances. And I can talk more about those, but effectively, part of the metadata that you use in the auto-scaling group is you'd have to define what AMI to boot the instances with. And so the idea is that when you export your Packer image, it'll give you an AMI ID. Those AMIs can be seen on the Amazon console. And then in part of our Terraform configuration for our auto-scaling groups, we actually set the AMI ID to be the proper one. So a workflow that's common while I was developing the AMI is, you basically realize there's some new dependency or some new command I want to burn into the AMI. So I edit the Packer definition. I run Packer. I get the new AMI ID for the new image. I maybe delete the old image that was up there if I think it's no longer needed, and then basically paste that AMI ID into the Terraform configs, and then I run Terraform apply to basically update the auto-scaling group configuration to use that AMI.
And that'll get rid of the existing machines that are on the previous AMI, or?
It does not actually. So Terraform, there's different ways you can configure it, but the way that the auto-scaling groups are configured, if you just change that kind of metadata, it won't have to tear it down. There are some categories of changes that require it to tear down the existing auto-scaling group.
But any new machines it spins up would be with an AMI.
Right. So just a quick aside, auto-scaling groups basically point to a launch configuration, and those you can actually pin and unpin those to an auto-scaling group without having to recreate the auto-scaling group. But there are other things that are on the auto-scaling group that require it to kill it and create a new one. Terraform has a nice feature where if it does have to actually do that, you can tell it to, and we're set up so it will do this. It will actually keep the existing auto-scaling group instances up and then create the new one. And then only once a certain minimum number of nodes you specify have been brought up in the new one will it terminate the old one.
And then switch. Does it handle switching the DNS and all that stuff? Do you
Yeah, you can get it to work to do that. So in fact, Terraform itself won't necessarily have to do that. It basically just boils down to making sure that the new auto-scaling group points to the right load balancer, and that when the instances come up, if you are going to use DNS, that they register themselves and so on. So you can, in theory, make it so that it's a seamless transition. I think the catch is, of course, your application and so on needs to support seeing nodes disappear and reappear and have it not break a lot. Mm-hmm. For a web app, that's going to be easy, but for what we're doing, it's going to be a lot of work probably to get it perfectly seamless. Cool. And so that's Packer Terraform. Next up is Habitat, which you guys have probably heard me talking about. I'll just state it here, what it kind of does. It's a little bit hard to describe succinctly because it's kind of a number of things. So the way to think about it is it's a kind of holistic framework and runtime system for configuring, deploying, and running services, right? And so, so what I mean by this is it has a few pieces. It has a package manager and format. It has a runtime supervisor, which runs on each node in your infrastructure.
It's funny because when you write it like that, it sounds identical to systemd.
Oh yeah. And then it also has a centralized depot, which you can run your own, which hosts packages. And then it has command line toolchain for creating packages, running services, and a configuration definition language to allow dynamic updates of configuration of running services. So the way to think about this is these are all things that you basically usually have to build to some degree yourself, maybe except the package manager. So you will have to figure out a way to deploy configuration changes. You're going to have to figure out a way to how to do updates of new code to your servers. A lot of the stuff that we were doing with Ansible basically gets replaced by this. And so this allows us to build a package, push the package to Habitat's depot. Maybe one day we'll run our own. The nodes are all running Habitat supervisors, so they know what services are actually running, and they're actually responsible for keeping them up. And then when the supervisors recognize the existence of a new version of a package, they can actually auto-deploy it out to production as well.
So you do not expect people to build new Packer images very often.
Packer or Habitat packages?
Packer.
Oh, right, yeah. The Packer AMI should be relatively low change rate.
Unless you need to Habitat itself.
Right.
Very often.
What's that?
You don't expect nodes to disappear and reappear very often.
Sorry, I'm not following. Those are...
You don't expect nodes to disappear and reappear very often. I thought this was an implication of the fact that the AMI is just a generic Habitat AMI, and you just explained that Habitat can update stuff dynamically at runtime when there are updates to packages. So I don't know why we would be bringing down.
Well, but they would still auto scale, right? So like you'd still like bring up and down instances based on load. Right?
Okay.
Sorry, what does it have to do with Packer?
Sure.
What does it have to do with Packer though? Maybe I'm just missing the underlying point that you're asking. Like,
I don't know if it had to do with Packer. I just wondered whether it was a true statement.
Oh yeah, I think in general we don't expect nodes to be dying out of our control. I think it'd be nice if we built our software so that it could be resilient in those cases.
But not in our control either. Like, we don't plan to, for example, restart nodes when we make typical changes to our software.
Well, when we do a deploy, whether it's config deploy or a code update, we'll restart the services across all the nodes.
But the nodes themselves...
We'll restart the services.
Yeah, we won't restart the nodes, right.
Okay.
Yeah. Yeah.
Question also, the fact that it's a centralized depot, is there any concern there for like if it's needing to, for example, autoscaling is needing to autoscale and that depot is not available?
Right.
Like, shouldn't we be considering actually hosting our own, because that way we're not reliant on this other service as being at their
Yeah.
time?
Yeah, we can.
Ours is going to be up more often than Habitat's, because I disagree with you.
At least we can like address it if it's ours.
I guess I kind of assume that we can always just go and manually put packages onto the nodes if we want in any kind of emergency. So
Yeah, I think there's one actual. So that the availability is definitely a concern just because it has gone down. Right. I think there's other reasons that we might want to run our own depot. So Habitat, each package obviously has versioning, but it also has this thing called channel, right? And so channel can be either unstable or stable. And basically the channel is really your only tool to navigate which nodes get which package, right? So like basically right now, when you upload it, it's unstable, and then you can graduate it to being stable. And when you run services in production, the only thing you can say is what channel should these be on. So stable and unstable is great if you either have stuff you don't want to run and stuff you do want to run. I think in our case, we probably are going to want 3 channels. We probably are going to want stuff we don't want to run yet, and then we want to graduate it to stage, right? So it's going to be visible on some nodes and not others, like we were in general to stage it. And then you're going to want another channel to push it out to production. So the point being that in order to do that, you do need to run your own depot. They don't have the ability to customize the channels on their.
You mean production. You can't specify versions or version ranges or?
The contract is that the supervisor will always run the latest version in the channel. So basically, like, you can decide which version you pin to the channel as the one to run. But the service runtime is bound to the channel, so it's always running
for like packages that have like breaking
version. Call it a new package, I guess.
Yeah, would that be? I don't know if you have a dependency on some library or some service or whatever.
Yeah.
Of a specific version.
Mm-hmm.
And then they update it.
Oh, well, you define dependencies, so you can. So the packages themselves have metadata as well of their dependencies, and those can be either typical Semver type things. You can say, just give me the latest whatever, give me the latest within this version depth, right?
But you can't do that for.
Probably not Habitat, right?
Yeah. Right, but Habitat has packages that have dependencies. Why does your package? Why do packages you create not also have versions, and then you can deploy? Also, like you can deploy specific versions of dependencies, but not specific versions of root things, whatever.
Right. So when you run a service, you don't specify like a version specification for the service to run. You specify what channel to bind the supervisor to.
Service is different than packages.
Each package can optionally have a single service that it defines. So basically, like, a package can just be a binary blob that's going to just be a dependency that gets installed, or it can be that plus a definition of a service that it runs. And
if it has a service, that service, I'm just confused as to why you'd be able to specify dependencies with version with Semver stuff, but not. How do you define like what these root packages you're installing are, or whatever? Like Reticulum has a package, right?
Right.
And that has a service defined. How do I define that this package is getting installed? And can I set a version there?
Right. So basically, so there's runtime dependencies, right? And so those are defined in the package definition.
Mm-hmm.
So when I write the Janus one, I have like a huge list of crap that it needs to run, right?
What's pointing at Janus one?
And so basically then you have the ability to always install packages, but then a separate action you can take is to start a service. And so when you start a service, you specify what package the service is from, and then you also specify what channel to use. You could, in theory, they could have a feature maybe one day where you could also say only run these
when
versions.
You're specifying that package, you don't specify a version. It's always the latest version of that package.
Correct. It's you give it the package name and the channel. So basically, it's saying, hey, this service should continually. The invariant is that it should be running the latest version of this package's service in this channel. So, I think the version number stuff, it's kind of orthogonal anyway, right? Because in practice, when you're running these things, they're your packages most likely, or they're ones that.
I mean, you have MongoDB, right?
Right.
That's going to be a package and a service you want to run.
Right.
You're going to want to run a very particular version of MongoDB, probably.
Right. Well, you like for Mongo, for example, like you would probably not set that up to auto deploy anyway, right? So like you probably would go through a typical manual rollout of a new version, right, explicitly.
But like, if the Mongo package updates, now your service is going to get upgraded as well. Right?
No. So something like a database, right? You would not set up to have this feature turned on where it will just maintain the stuff for you. Like you will basically have more. You would want to manually go through it. You would write an Ansible script to deploy a package like a traditional way. But as a more in a way to have you not do that, right? Habitat offers the ability for you to then have auto deploys happen, and the contract that they have for that is not version based; it's channel based. So it's like, you just want to have some channel you define. So I think that will work fine for us. Generally speaking, my expectation is that when a commit lands on master for the things we care about, it will automatically package and deploy to unstable. We probably will have some cluster running that is deploying unstable to start because we're going to be using their depot, and then your go to prod action is basically just promoting that package to stable, and then Habitat will just take care of the rest.
Sort of like web interface to do that or something? Or
just command line right now.
Yeah.
So we probably will write an Ansible script or get it wired into Slack or something like that.
And I assume you have to be authenticated to do that.
Right. Yeah. So
you're the package owner.
Right. So to actually do that, it's actually based upon your we actually have a series of keys that are involved in authenticating, like that you're allowed to do certain actions within Habitat. Yeah, and then not to mention that, but we also have so the Bastion host is effectively just an SSH tunnel. So there's only one server in Amazon that has SSH exposed to the internet, and I have scripts set up to basically work with that. And so you would also only be able to do anything if you could get to that host, and you would need the SSH key to do it. So
is Bastion a piece of software or just?
It's just a name. It's just like a dumb host, yeah, that sits there with the right setup. Cool.
Why did you want a jump res?
Just good security practice.
I guess it sounds like a big thing, but
yeah, I mean it's pretty standard. I think if you don't have a VPN, so.
RDS handles its own scale.
Well, RDS.
I mean, like,
yeah, I mean.
If we needed to, we configure scale on that. I mean, it's not going to be part of the auto scale, right?
Oh no, yeah, RDS would still be defined in Terraform, but you would basically specify like how many read replicas you want, and when you apply it, it'll just crank out new ones, probably.
But that's not.
Yeah.
That doesn't have to auto scale it.
No, yeah. Like you basically have to say how many replicas you want. I mean, it probably depends somewhat on the database server it's running. Like MySQL, you could probably have multi-master, but I think it's not going to like automatically just add resources without you telling it to. Cool. I'm trying to think anything else. Let's see. So those are the big pieces. So I will now I guess go through a few of these. So the first, I guess I'll do it from the top down. So let's start with Terraform. So, well, I guess first things first. There's a repo, Mr. Ops, and basically in here we've got bin directory that is just scripts you use to SSH into the machines, which I'll show you. Ansible, which are Ansible scripts. Right now, the only reason we're using Ansible is to do config deploys. So if you want to update configs, you have to run a few commands and upload some files to the servers to run the Habitat command. So that's
what kind of configs are these?
Right now, it's just Janus. So it's like the ports and the DTLS key and cert.
And those are not part of the packages.
Right.
And they're not part of the packages because the packages are public and should be usable for other things. So like,
yeah,
the packages should be generic. So like, you have stuff as separate configs for that reason.
Well, so one thing that's nice about Habitat is that part of your package, unlike other package managers, like it also has a story around how you define configuration, right? So each package exposes basically a key value map of configurables, and then your job as the package maintainer is to basically give Habitat templates to generate whatever configuration files that service needs. And so what this is basically Ansible scripts that will let you deploy Janus configuration out via Habitat. You never have to actually interact with Janus's configuration files.
But isn't that just updating whatever inputs to Habitat? Like you said, Habitat has this key value thing for a package.
Yeah.
So all you're doing is updating that key value thing you're saying, and then telling Habitat to update the config.
Right. So you feed this generic, so all of our configuration for all of our services will be in this TOML format. It's just like, it looks like an INI file. And like, you won't have to care about what the underlying service does with that, like whether it lives in files or whether it goes to like a bunch of things. It's all encapsulated by the package. And so basically these Ansible scripts are responsible for applying those TOML files into Habitat.
So are these Ansible scripts just running a Habitat command, basically?
Basically, there's two ways to update configuration. There's applying those key value pairs, and then there's also just straight up file drops. So basically, like, we need to do both for Janus in particular, because Janus needs the configuration, obviously, but then it also has some files it needs, like the DTLS key, and those are not part of the package, obviously.
And you can't specify those as part of a configurable? Like as part of the key value thing?
Right, yeah, those key, like just Janus itself looks for a file,
something?
yeah. It just looks for a key file.
But I mean, like Habitat doesn't allow you to specify a file as a configuration option, basically, like or something.
It's like kind of implicit, right? So like, it's part of it, the way it's exposed to, say, a person that wanted to use our package is they actually, as part of the documentation, will see that to set your DTLS key, run hab file upload and pass it your key file, right? Just because the file.
So you can tell it to upload a file, though.
Yeah, like you just say send this file, and then as the package maintainer, you set things up so that if they were to upload a file with that name, it will automatically be used as the DTLS
So the Ansible script is literally just running a bunch of Habitat commands.
Yeah, it's uploading files, and then it's running Habitat commands on the SSH.
The uploading files happens through Habitat as well, though, right?
Well, Ansible uploads the files, right, and then it uploads the file to AC2, and then it runs a series of Habitat commands that then publish those to the supervisor ring, right? So the way to think about these configuration changes and these files, it's not like they're just uploading files; they're actually publishing them into the ring, and then any service running that needs those configurables will then both generate the configs off the new data, drop the files if there were new files that were published, and then restart the services as well if needed. So so it kind of does all that magically, which is kind of cool. So
I feel bad about going into the Janus configuration rabbit hole, but I feel like I'm confused about why it's happening this way. Like, okay, so I understand that we need encryption on STTP connections, which is DTLS, but that doesn't need any particular key. I would just want Janus to generate that key when it starts up, or the box to generate that key, and the AMI in it, like it just needs to be a private key.
Yeah, we could do that too. That's fine.
Oh, okay. But then there's also, like, presumably when you're connecting to Janus as a signaling server over a WebSocket, you want some actual authentication. So I don't really know exactly how secure WebSockets work, but I presume that you might need like an actual signed certificate.
Yeah.
And that, I guess, I would expect to manage using, like, honestly, if it were me, I guess I might use CloudFront for that.
Yeah, I think for our
have,
SSL
like,
certs
or something like that. I don't know. So is that part set up?
Well, so right now the secrets management story is basically encrypted files checked into the Git repo, and then Ansible provides a nice way to just automatically decrypt them and land them. So the DTLS key is actually checked in, but it's encrypted.
Okay.
And
so that one will just delete. It's like we don't want the same one on every place every time.
The way this is implemented now is they all will have the same one. If that's problematic, we can fix it. But basically, that's just up to us. But in terms of secret management, right, this is what we have today. You could imagine another flavor of this would be a more sophisticated setup where there's a service running in production, or we're using an AWS secret management service, and then any secrets are just kind of pulled from that on this server side.
So is like TLS over WebSocket set up at all right now, or not?
No.
Or like, what about Reticulum?
So the way that we're probably going to do SSL termination is probably at the ALB level anyway.
Okay. Great.
So like the SSL cert will be configured completely on Amazon's side.
That makes sense to me. I just don't know if it works with WebSockets.
Yeah. So I basically the way I have things set up now is that the Reticulum services expose the WebSocket Janus port and the RTS port directly to the internet, and then the Reticulum HTTP port is firewalled to the ALB. We can change that. I wasn't really sure, so I just set it up that way for now. I didn't know if we wanted the Janus WebSocket A to be encrypted, how much we care, and B, how much we care about connecting to the node directly. So we can talk about it. Like, it's easy to change that stuff.
Okay, it seems to me like that has to be encrypted, but I don't really know how it should work because I don't know about WebSockets.
Cool. I also don't have like access to any of our SSL keys for the wider org, so that's why I registered a domain for us, so we can at least have a SSL cert for it. Cool. So Terraform. So so the repo. So So we've got Ansible. I'm just working on a branch with everything, which is kind of bad.
So we don't know how to create anything on Mozilla.com or Mozilla.org domains?
Not right now.
Okay, who knows that?
I have no idea. I would ask Emily first, probably,
Right.
if we care. So then that's what's in Ansible. Bin I'll talk about. Packer Habitat Scripts is just some stuff Robert was working on to bootstrap the service on his computer. I'm not sure what we want to do with that. Then Packer is basically where all the Packer definitions live. So like I mentioned, there's two images. There's the Bastion image, and then there's this Habitat base image. So what's in here is this is really the key thing. This is the image definition. So for the Habitat image, I did do something a little kludgy. So there are some secrets involved. Like we want to drop some of the Habitat. We actually want to burn some of the keys in for Habitat into the AMI. I don't know if that's bad security or not. I don't think it is, because the AMIs are basically only accessible from our infrastructure. But anyway, I wanted to check those in, so this was turnkey. So there's a little GPG and encrypted zip file, and there's a shell script to run and build the package for this one. But you know, these are easy to change, and if this seems dumb, we should fix it. But like I said, these AMIs I don't expect to be changing very much, so I didn't want to like over-engineer a key solution for
How does that
for
get
Packer.
encrypted?
Oh, it's just the magic password that I think Kevin's the only other one that knows it now, but we have one master password.
And that happens when you run Packer to create the thing, it'll ask you for the password?
Yeah, you just run this build script, and it will it'll prompt you, and then just do the build.
Okay.
So, yeah, I think the one gotcha here, actually, now that I think of it, is every service group that we run in Habitat gets a dedicated key for local encryption among the service group for configuration, basically. And so if we do add new services, that is one case where we do need to rebuild the AMI. So as we add new services, those are rare events, but they will be non-zero. So like when we add a new service, we have to come in here and add the private key for the service group local encryption to this zip file. You literally just need to add it to this. You don't need to change anything else. You just need to add it to this key file. So that's what's in Packer.
And that build just spits out literally an AMI onto Amazon.
Right. I mean, I can even show you. Like, I'll just do it so you guys can see. So like we can rebuild the Habitat one. So here I am in here, right? If I just run build, it's going to ask me for the passphrase, which I'll tell you guys. Any place where we're doing passphrases, I'm just using the same one everywhere. So
Same as Rail app.
No, it's its own thing. So basically, like the SSH key is passphrase encrypted. This GPG file is. The Ansible Vault is password encrypted. So I'm just using the same one for all three of those. So that's Packer. So you can see it's just doing its thing. So it's spawning an instance. It's waiting for SSH, and so on. Plans are basically Habitat packages and their plans. So there's no binaries in here, it's just plans. So let's look at like a really simple one like Opus. So we have a Habitat package we publish for Opus now. It's super basic. There's only two things you need in there. A plan SH, which is this plan definition. This is all Habitat specific stuff that is metadata for the package. And then this default TOML file, which is, I think in this case, empty, but this is the configuration definition. So if you're ever wondering like, hey, what can I configure for the service for this package? You pop this open, and that will give you both the fields you can configure and also the default values.
And does this also define the template for the configs, or is that part of the SH script?
You will find that in the plans directory. So like if I were to go to Janus Gateway, which does have configs, you can see there's a little bit more stuff in here. So here's actually the configuration files that it will be generating.
Okay. And these are templates that then get filled by the
Correct. So it's a templating language like handlebars, and it's pretty straightforward, but it's all encapsulated from the user of the package. And if you were to go into default TOML here, you can see I wrote this file. This is like the ground truth for what configurables there are for Janus. And your job as the package service runner the person who's running it is to just go through this and decide if you want to use any of these options.
And so these are all just default, and then
Yeah.
And then where do the actual values go from?
So, when you run the service, it uses this to generate the config if there's no overrides, and then the overrides can be published dynamically to the ring. And so the ring, is like the kind of thing where the state lives within the ring, so there's no backing persistent storage of the ring state other than the ring itself. So, as long as there's one healthy host in the ring,
and if the whole ring goes, it's
all the overrides are gone. Yeah.
That sounds so strange.
Yeah. So you basically want to run a ring that has at least like 3 nodes, right, to have it be relatively durable.
So we want that stuff checked into Git.
The values are checked into Git. Yeah, they are.
Okay.
Well,
They're in the Ansible. They're in the Ansible folder.
Oh, okay.
Yeah.
Because you.
How do you
update a value then? So, like, say you want to update a Genus config option and override.
Yeah, you basically go into the Ansible scripts. In there, this is the override toml.
Mm-hmm.
So you basically edit this. These are all of our overrides
for all the services.
This is for the Reticulum node type. So this will be both Reticulum, and there'll be a template for Janus and a template for Reticulum in here. And then you run an Ansible script to deploy it. But and what that means is you deploy it here. The configuration state gets gossiped throughout the ring, and now you can tear if you tear all the nodes down except the one, it will still exist, and you can bring up new Reticulum nodes, and they'll be configured with the latest deployed configuration. If you were to tear it all down, then you would necessarily have to redeploy the config to the ring so that it had it. But in general, you'll see I'll explain why that's an unlikely thing to happen, hopefully.
The fact that we have these backed up in Git has nothing to do with Habitat. That was something we did.
Yeah, they're in Git just because they need to be somewhere. But yeah, like the actual.
But Habitat doesn't care about.
No. Yeah, it's not
existing in a file. Like you just ran it just runs a bunch of commands to set these overrides.
That
exist in the ring.
Yep.
The fact that you have a local copy of the file is just incidental.
Right. Yeah. Like this is the ground truth of what we expect to be deployed. So probably similar kind of workflow. If you want to make a config, the formal process is you branch it, PR it, merge it, and deploy it in one logical step. And now the ground truth is on master. Similar idea. So then Terraform is kind of where things hopefully don't get too confusing. So basically Terraform is a bit of a beast. So the way it's set up is actually, I think, pretty darn good. But in general, it might be a little bit of a learning curve. So, because as I mentioned, we're not just doing Terraform, but we're doing TerraGrunt style Terraform. So it's a little bit kind of different. Generally speaking, the overarching goal of the TerraGrunt thing, I think there's 2. The first is making this stuff as dry as possible, right? So there's not a lot of cut and paste. And the second is that it's making it so that we can deploy multiple copies of our stack into Amazon. So like with this setup, it's much easier to say have a dev environment and a prod environment that have the same overarching structure, but might have different knobs turned up or down, right? So for example, like you might have like a 50 node cluster running in prod and a 3 node cluster running in dev, but you still have the same fundamental structures that drive that, right? So the way it breaks out is Terraform has 2 folders. There's live and there's modules, and this, I didn't make these names up. These are just part of that whole style. So the way to think about it is modules is where the kind of fundamental definitions live that are environment agnostic. And when I say environment, I mean like dev versus prod or QA or whatever. These are where the actual Terraform scripts themselves live. And so these are all names I made up, and the breakdown of these are based upon my own decisions around how to modularize the stuff. So each of these folders is its own kind of distinct subset of Amazon resources that you kind of logically want to work on at one time and probably apply to production at one time. An alternative way to do this would be to make one gigantic module with everything, but it's just easier to deal with if you conceptually break these out. So basically, base is just my kind of bucket for throwing stuff that doesn't really go anywhere else. And it's kind of the stuff that needs to be deployed before you can build anything up from scratch. So if we were going to deploy a new environment, you would run this one first. Probably actually run this one first. VPC defines all the networking. So this basically defines public and private subnets and the VPC and the internet gateway and the NAT and all this crap that, you set it up once and then you don't ever think about it again, but it's got to be set up right so the networking works. And then base sets up a few things like our EC2 SSH key. It also creates a default IAM policy for all the nodes for security policies we want to have be available to all the nodes. One design decision I made that I kind of want to make sure is okay is that to make my life easier, all the nodes in EC2 have the ability to query the state of the EC2 instances, so they can actually query Amazon's EC2 API in a read-only way and just check what instances are running. This basically just makes it a little easier to bootstrap things like the initial ring and things like that, because it can check to see what other nodes there are. So those two are kind of general. The Bastion one is the resources to define the Bastion node. So one thing to point out is we're never running EC2 nodes on their own. We're always running them within an auto-scaling group. And so instead of, say, having a single EC2 node running, I define an auto-scaling group and I assign it a size of 1. The benefits to that are A, if that node were to die, it will just recreate a new one. And B, it also makes it so there's one single pattern for managing instances and all this Terraform stuff that you have to understand. So the Bastion is probably a good motivating example. I don't expect you guys to totally grok all this stuff, but in general, there's kind of a preamble of stuff that's just you cut and paste. It's just going to set some things up that are the same across all the different modules. The next set of things is loading state about other modules. So if there's, for example, we want to be able to reference the VPC resources or things defined in base, which are like the SSH key, we need to actually load the state about those objects off of out of Terraform state files. So basically the way Terraform works is when you apply it, it actually maintains the state of the world in a file. And the way I have things set up, which is also kind of best practice, is the files live on S3, and then there's a synchronous lock that you take out at the module level via DynamoDB table. So this makes sure that only one person can be applying configuration at a time, and also the configuration state is durable. It won't ever get lost. So it should be pretty hard to fuck it up, and it's really bad if it gets fucked up, because now you have a disconnect between Terraform and the actual state. So
so it doesn't actually read the state from Amazon or anything.
It does, but it still needs to maintain a lot of state itself. So for example, you want to make it so that it won't just say you went in and you manually created an EC2 node. Mm-hmm. You don't want Terraform to just delete it right when you apply your local changes.
Wait, why not?
I would expect.
That's what you would. That's what you would expect. But I think generally speaking, they don't want that to happen, because then everyone will just be breaking things. And that's one example of things where Terraform knows what resources it's created, and it knows which resources it's responsible for. And the happy path is if you have existing infrastructure, right? That's the reason probably is you have existing infrastructure. You don't want to nuke it by mistake. So the happy path is you then import it into Terraform's umbrella, and then Terraform manages it. So these state files are basically critical for being able to ensure that it has a consistent view of things. So anyway, the point of it is just that if you want to have these modules broken up like this, the only way to pass information across modules is by having each one load these state files at startup for the things that it cares about. So each of these has effectively 3 files, and output is basically the variables that you want the Terraform module to explicitly export to other modules. So for example, when we set up our SSH key, we want that to be seen and be able to be used by other modules, so we include it in the outputs. And so the idea is that once it's in the outputs, that guarantees that it's going to be queryable from the data file. And then you'll see in this module, we load the base state file, and then we also can reference the SSH key from that file. So So it's a little bit roundabout. Like this, I think, is a side effect of the fact that like people are trying to make this stuff dry and modularized, and it's not completely clean. But this is today, I think, considered the best way to do it. And so I'll just really quickly go through like this Bastion one. So we create an AWS security group to whitelist the SSH port. Obviously, there's egress and ingress firewall rules, and then we create the IAM role. So like if you remember from our last project, we had to do this part manually. Now we don't. And then we create a launch configuration for the auto scaling group, and then we create the auto scaling group to actually cause the nodes to start. So two really quick things to mention. You probably notice like lots and lots of these things are dynamic, right? There's not a lot of hard-coded stuff here. It's all driven off of other data, whether that data is variables or data from a different module, and so or data from other resources that were spun up. So so referencing resources within this file is kind of the one of the key things Terraform lets you do. You can bind these things to each other, and it manages which ones have to be created in which order. Referencing outputs from other modules, that's I already talked about. And then also you can reference variables, which are effectively environment-specific values. So like, for example, when we're never going to run more than one Bastion in this example, but let's say for Reticulum, we want to run like 30 servers in production and one server in dev. Like by using a variable for that makes it so we can have that knob that's environment specific. And I'll talk to you guys about how the variables work after this. The other thing worth mentioning is Amazon has the ability to tag instances. We use that a bit at I'm going to keep calling it our last project, but we used that a bit before. But I'm using it as well now. So effectively, this is what I'm doing for bootstrapping of service discovery. So like, we want to use Habitat as much as we can for service discovery because it has health checks and it can tell you the most up-to-date view of what's actually running. But for bootstrapping the basic pieces, discovering other nodes that have Habitat or discovering like the Bastion, like these things that are at a lower level, I'm using EC2's API as that mechanism. So by having tags on the instances, it can make kind of heuristic decisions around what nodes to use to join the ring and so on. So so every EC2 node has a name. The name is not unique. So the name you should just consider a visible label, but it's not unique. There's actually still today, as best I can tell, not a way to get auto scaling groups to generate a unique name for the node automatically. And remember, like this file is not generating nodes. This file is generating a scaling group. So it's not like I could just like generate some name here. It's going to just, the auto scaling group is responsible for applying these tags. And then it has an env, which is basically just the environment. So right now there's dev, there's going to be prod. So that's, and by the way, all the names of all the resources have the env in them as well. So you'll see that we have dev for like everything, the VPC, the nodes, everything says dev in front of it. And you need that because a lot of the time Amazon doesn't let you have resources with the same name. And so, by the way, there's a difference between the resource name and the name tag. So not to be too confusing, but the resource name is a more fundamental thing, and it's really resource specific, and that is, I think, often enforced to be unique. But the name tag is literally just a tag that heuristically AWS will use in its UI to draw a name for the value for the thing across all the services that they have. So we have env, and then we have host type.
I reached my limit of being able to absorb any of this information at 5x verbally.
Yeah, sorry, I'm recording it, so
okay.
Yeah, cool. And then we have the host type, and so the host type is basically a way to say, hey, what nodes are out there that are Bastion nodes in dev? Give me a list of those. You basically can just query the Amazon API and get all the nodes that have that host type. So the host type is now not just that it's a Bastion node, but it's also a dev node. So I couple the environment together because that's usually what you want to do. Okay, so right, so Packer is just stuff for Packer. I won't get into it. It's just stuff that Packer uses. And then we have two other ones. We have Hab and we have Ret. Okay, so
Wait, so Packer's actually aware of Terraform?
there's just like some security groups and stuff that I set up and firewall rules so that when Packer runs, it can use those. Yeah, like just to create its thing. Yeah, I just want to not do too much fire hose on you guys if I can avoid it. But I think one thing I was realizing. So the reason that we have HAB and RET. So RET is reticulum. HAB I'll talk about. So one way to do this was like. Okay, I guess the motivating problem here is like when a node comes up, it needs to join the ring, right? And the only way to join the ring is it needs to know another node on the ring, right? It can't just bootstrap up off of nothing. It needs to figure out an IP address to connect to. The second problem is that you don't want the ring to ever all go down because you'll lose all the configuration, right? So to solve both of those problems, what I did was I created 2 categories of node right now. We have reticulum, obviously, which is for running reticulum. But then we have HAB nodes. Right now, you can have just one. But basically, it's there in order to do a few things. It's the fallback IP address to connect to. It basically maintains the ring when all other things have blown up. And it's the thing that is going to always be there. If you do tear down all the reticulum nodes, you don't want to lose the configuration. So you want to have some nodes that their only job is to just chill out in the ring and just be there to bootstrap other nodes if those auto-scaling groups get torn down. So that's basically what I did. So the HAB nodes are pretty generic. They don't run any services. They do expose the ports to gossip on the ring. They have pretty basic security policies. It's basically like everything a reticulum node needs, except no reticulum, right? It's just the basic bits you need to be a node in the supervisor ring. And then the reticulum nodes have a bunch more stuff. They have an ALB, the reticulum module, I should say, creates an ALB for reticulum. It has a bunch more ports exposed because we have all the Janus stuff.
Is the reticulum node based on the HAB node or the module?
It does not. It's not dry in that sense. No, it basically it's a separate auto-scaling group, and all these other resources are separate. Okay. And then the other thing worth mentioning is, so if you remember, the AMI gives you both the bits and the running supervisor, right? And so when that AMI boots, the supervisor's up out of the box. It's not running any services though; it's just sitting there on the ring. So the job of in order to actually start services, the services we start actually are dependent upon this auto-scaling group. So like the reticulum auto-scaling group, those nodes, their only difference is that they're going to start a subset of services on them. They're going to start the Janus service, they're going to start the reticulum service. So
based on launch configuration?
Right. So basically that the way that you tell the nodes to do something special within the group is you define user data as a shell script, and then it will just run that shell script on startup after all the other stuff the AMI does. And so so I have this little shell script that works. Basically, it sits there in a spin loop waiting for the supervisor to come online, because I think there could be a race condition there I was seeing. And then this is the generic command to start a service. So the only thing that's going to change between services is just the package name. So the package name, in this case, this is going to just start Janus. But then these things are shared across all the services, so you don't have to really think about what these are going to be. I shouldn't say that. The strategy is one thing that might change. So the strategy is basically when you deploy, do they get updated all at once, or do they get updated one at a time? The reason I'm doing it at once is in order for you to do one at a time, you need at least 3 nodes. I won't get into why, but basically just to get stuff working, since I'm only doing 1 node at a time, it needs to be all at once. The URL is the depot. This is the depot URL. When we run our own, we would change this. And then the channel, like I mentioned, when you run the service, you bind it to the channel, and you say, this is stable, so this means like this node is going to always run the latest stable version of Janus, whatever the hell that is. And then the strategy implies, by having the strategy, it implies you want the deploys to happen automatically. If you left the strategy flag off, then it wouldn't update on its own. So one day this will just be basically this, right? And then actually, eventually, it'll just be one thing again, because right now Habitat is working on having packages that their only job is to be composites of multiple services. So we'll probably roll everything up into one at some point. Right. So yeah, sorry, this is like so much shit. And so that's the module part. So these are basically the meat of what resources are defined. But then, as I mentioned, there's environment-specific variables, and that's basically all this is. There's some kind of useless boilerplate that you have to stick. For example, like all of this stuff bootstraps out of Git. So, you know, it's going to pull from Git. I'm trying to remember where that comes in. But anyway, there's just some boilerplate. But effectively, these are where you stick the variable values, and you also define dependencies between modules. So, for example, like here's the Bastion thing, and I expose 4 variables, and those should be actually one-to-one with the variables defined in vars tf. So you can see there's 4 variables exposed by the module, and then each environment has the ability to set those values for its own environment. So TerraGrunt, basically, like you can work with it one of 2 ways. You can either like run each module by hand on your own and apply it, or you can just do like apply all, and it will just like apply the whole gigantic monster. Like, and the way it does that is you define these dependencies between the modules, and then it will only do, you know, the first set of modules and make sure they apply before it does the rest. I've been generally working on it one at a time just because it's faster to iterate on, but it's probably good practice to just apply all of them every time. I think, you know, if you wanted to go really crazy, you could do this as part of CI. I think ops people I've talked to, like, or seen, not talked to, but seen writing about, they're even too terrified to do that, even though it seems like it should be logical. Like, you could imagine you merge to master and then it updates your Amazon stuff. Mm-hmm. But I don't think anyone has quite gotten to the point where they have the guts to do it yet. Cool. So that's Terraform.
And how do you run any of those individual things?
So you basically run TerraGrunt. TerraGrunt's a command line tool. Mm-hmm. So I'll show you one example. So basically, if I go, let me just see if it's in this. Yeah. So if I want to do it one module at a time, you go into the live directory. You go into the module you want to run. So let's say we want to, I don't know, do a no-op on the Habitat module. So there's right now one Habitat node running, and it's sitting there. But if you want to, like, so the first thing you would do is, to be safe, you would do a plan, right? So there's 2 main commands in Terraform: plan and apply. And plan tells you what it's going to do, so you don't, if it doesn't do it, so you can sanity check it. And apply will apply it. So you basically just do this. I guess it's good to have it in the video here. So you have to point it to the module path explicitly. Oh, I should mention that
so
this
you're
is
in the live path for that, and then you point at the module path.
Right, and what I should mention though is that you do this only if you're making local changes. So if you are just going to like run what's out of, if you just want to run what's out of Git,
which
then
is probably what you want to do.
Right, like you just don't have to say this. It'll use the Git URL that you saw in the files to pull down all the Terraform stuff. So actually, here, this is one thing I'm remembering now. So we have both live and module in the same Git repo. It's kind of often the case that people have those in 2 separate repos, and so what you might sometimes do instead is you just check out the variable repo, the live repo, and that's where all the variables are for the environments, but you don't actually check out the Terraform plans at all. And then you can just run TerraGrunt, and it'll download the Terraform plans out of the other Git repo. So that's why the Git repo is there. I didn't do it that way, though, because I thought that was dumb.
Quick question. I saw it complained about you having those slashes. I noticed that earlier in your Terraform file for your live, in the URL for your GitHub. You have, like,
yeah, that is
is there a reason for that?
No doubles. Oh, yeah, this is this one. You mean? So this is just a Terraform thing. So basically, if you have a Git repo source, it defines just heuristic where you need a way to separate the Git URL from the path. and then it uses this double slash as the way to know. Otherwise, if you had it just like this, that would imply the branch name has the slash, it's not a part of the file path. Yeah. So cool. And then so that's basically dealing with AWS resources. I guess I'll probably break this video up once it's done. Let me make sure my disk is not full yet. Okay. Oh God, I hope it's recording. I think so, right? Oh my God, is it not recording? Oh, 609 megs. Okay. Okay. So that is like basically Terraform. Let me talk a little bit about the just like dealing with boxes in production. So, okay.
No, it's good.
So if you go to EC2, right now we only have 3 hosts up, 1 for each type, right? So there's RET, which is the reticulum box, HAB, which is the habitat ring guy chilling out, and then the Bastion, which is going to be just the SSH jump box. And then, of course, you have 3 auto-scaling groups for those 3. And they're all running 1 instance. And so, as I mentioned, the instances are all tagged. So you can see I actually in my own UI added host type as a tag to just see. And you can see they have a few tags. They have their environment. They have this tag is one-to-one with the environment and has the same name, but logically this is defining a name for the habitat ring they're part of. Because you can imagine when we have multiple environments, we have 2 rings, right? We don't want to have those rings merge because then we're going to be really fucked if that happens. So you want to make sure those can't possibly connect together. That's enforced not just by this, but also by.
They're not even on the same network, right? Like,
they will not be on the same VPC. Yeah. Right. So the network. Yeah, that's what I was about to say. Like the network and the firewall rules. But I wanted to make sure that this still cared. Yeah, I was just kind of being a little paranoid maybe, but. Yeah, and so basically, so the question is how do you get on these nodes? So, usually my model for servers is I usually think about each one individually and try to give them unique names and think about them as servers that I care about, each as individual snowflakes. I'm basically trying to unwind that because I think that's not the right way to think about things. What you really want to do is be able to get to a box that has a specific service running that you can deal with. Eventually, you won't even want to SSH at all, but I think generally speaking, I shouldn't often care about which box it is. Sometimes I will if there's something really specific going on with a specific box, but 9 times out of 10, I just want to get to a box of a certain type. And so basically then the way to do that, is there's this bin SSH shell script, and you just tell it what box you want to get into, and it will do everything it needs to do to hop through the Bastion, get you on a box that's live. For that type, and I actually made it so the prompt shows you on the left there what kind of machine it is. Now, the SSH command also allows you to specify an environment, and so right now deb is implied, but if we want to do prod, you just do that to get into prod, and so on. In addition to that, there's also tunnel, and tunnel allows you to open up a tunnel to a type of host. Mirror a port to your machine for an environment, and this is what is used for right now there's only really one port of interest, which is the Janus admin port, and so if I do this, it'll set up a port tunnel to Janus. Implicitly it'll use the same port unless I override it.
So Janus is on the reticulum node?
Yeah, so this is a response from Janus basically. So Janus is up and running on that RET node, and it's actually the admin port is firewalled off to just be on the local network, so that's why you need to tunnel it. Yeah. So hopefully, you won't have to learn crazy SSH commands. And the other cool thing about the tunnel for some reason, you have to Control-C at the end. But the other nice thing is that if you look at how it works, it's basically going to Amazon to get the metadata about what nodes are up, and then just creating the right SSH tunneling command to get into the node. Cool. So that's how you get into stuff, and Ansible does the same trick. So Ansible actually does the config deploys via the tunnel, but it runs the hab commands on the hab node. So it basically...
On any hab, it does just pick a node and then run it on that one? And then
it does, yeah, it just picks one. Right, it just picks one, I think, right now. Yeah.
Is there concern if we do multiple deploys at the same time, like back to back? Like, I'm assuming there is a delay then before the gossip actually fully.
Yeah. I think you should say like seconds. I think it's like seconds tops.
But it's also, I assume, eventually consistent. Like even if you tell two different nodes.
Yeah. It'll get the last one to come through. Yeah.
Well, not even the last one. I mean, it'll be just.
It'll be whatever.
Package. Yeah. Like,
yeah.
I mean, like if you, yeah, I think, yeah.
Cool. So, I'm happy to go through the package stuff next if you guys want. I don't want to burn you guys out, but I'm going to do it just to capture it. So, I think there's like kind of two. So plans is the directory where all the Habitat packages are. If you were to go to builder.habitat.sh and authenticate with GitHub, Kevin's already signed up for it, so he can add folks.
I don't even remember doing this.
Yeah, I had to do this one. The fuck? Come on. Ajax for the win. Yeah, so we have this one origin. So origin is the name that is used to describe the package maintainer set. So we have private keys that allow us to publish to this origin. And then we actually have a bunch of packages because these are all dependencies from Janus mostly. I actually have yet to publish Reticulum. I have Reticulum building, but I haven't published it yet. But most of these are just kind of generic Linux libraries and things like that were a bit of a struggle to get all built, but they all are there. Janus itself is probably the most complex of all of them. It has all those config templates, and then it also has a number of dependencies. Some of those dependencies are ones that we built, obviously, and then it also has a small little build script. Like Lightning tore through Habitat. To build packages, you go into this thing called the Studio. It's actually optional, but I like to do it. So Studio is basically a Unix jailed environment. When you're running on Unix, it's literally just that. When you're running on Windows directly or Mac, it does a Docker container. So when you start the Studio, you are in the same working directory that you were when you started it. And so basically the Studio is letting you see, like, look, if I even do PS, I don't have it. Like, it's a dumb, empty environment. There's nothing installed here, like, at all, basically. And so the idea here is that when I do there's a macro to do build, but you can also do a hab package build. It'll basically it'll run my plan in the Studio. It actually runs it. I think actually this will run it in another layer of Unix jail, so it won't pollute. It'll install the files into this, but I believe the environment, the runtime environment, is a separate. It's not a jail. It's a separate runtime environment, and so it does the whole plan and basically builds everything and packages it up. And then I'll just skip this, but it just does its thing. You can see it build Janus.
And then you're dumped out in a thing that would have Janus installed basically.
So actually, it's only building the package file. So if you want to actually install the package file, the package file goes into results. And then if you want to install it, you can, of course, obviously publish it to the depot first if you want to do it without the file being something you have to specify. Or you can do it like this. And then there's a hab package directory. You can see it goes into there. That was really fast because everything was already, I guess, downloaded. But, it's all living in here, all the different revisions that have been installed. Why are those all there, actually? That's weird.
Does this carry over from previous session?
Oh, I think, yeah, because I'm running it in Unix, it actually is the Studio persists across hab Studio enter runs, whereas on Windows and Mac, the Docker container is destroyed on exit. So yeah, the root directory is just /source. So there's a lot of stuff to this, but generally like that spits it out. And then if you want to publish it, you do have package upload. Okay, like just the latest one. I'm not going to do it, but you run that, it uploads it, and then that'll get it down the unstable channel, and then it'll give you back a package identifier, which is it's basically the full version number. So if I go to Janus Gateway, you can see that there's all these versions, and then this is effectively the way you specify a specific package, and then you can promote that package from unstable to stable. So you would give it like Mozilla Reality, Janus Gateway, 024, and then there's a timestamp release number, and then stable. This is the one that's already stable. Oops. And sorry, it's package promote. Right, and so this effectively would deploy Janus if it was not already the latest version. We can see it do it, actually. That'd be kind of cool. So let me just go... right, so we go into our ret node. You can see habitats. Oops. You can see the habitat supervisor is running. You can see that Janus is running. We can see its port. It's running on PID 3082. Let's make like a tiny change to the plan file. Or actually, I don't even need to do that. I just need to do Hab Studio enter. Let's build a new one. That's basically exactly the same as the old one. Yeah, and so it'll be a new package that has no real change. And then we'll publish it to stable, and then we should see the supervisor restart it. I'll take on the background. So that's the that's that set of plans. The other big hairy thing I won't probably get into here is the reticulum stuff. So where is it?
So does Janus always run on the reticulum nodes? Is that the plan? Is just keep them running together right now?
Yeah, so it's going to both be running on the same one. So typically, if you have your own first-party project, instead of having a separate directory somewhere else for the plan, you'll just stick a Habitat directory in your project, and that's where all the Habitat stuff goes. So I've already actually done all the plan for Reticulum. It's a little more involved because it has to actually do crazy Erlang-ish stuff to package it up for running it in production. This was like, a week's worth of work probably for me to really actually get it all working, but I won't get into it here. But needless to say, this package should just work, hopefully, on the node. I've ran it locally, so I just need to get to the point where the configuration definitions are sane and all the things we need to be able to tweak in production are tweakable. Like we need to be able to point it at the database. I think all that's kind of set up. So like you can see, we have the database settings. Now that I have a good story around secret management and all that stuff, all this stuff that looks scary to have in here will be part of an encrypted Ansible file. And so all of this should kind of close together now that I can cycle back onto it. Where'd it go? Where's my studio? Oh, it's still building.
And this builds from source every time, and
yeah,
we'll do incremental builds. I guess if your jail stays around.
Yeah, it should stay around. I think if on the Linux side, I'm going to basically just enhance this to also compile and include Marshall's Rust plugin.
And now would you normally run this on your own machine or?
Oh, I think this will move to CI. So right. Basically, so I'm going to trigger it off of Marshall's Rust plugin, and then basically the hope would be that if he merges to master on that, Janus will be deployed. So that may or may not make sense once everything's plugged together. It might be really disruptive to do that.
Well, I mean, isn't it just if you update any of these plans too, that would also rebuild them?
Oh yeah, we could trigger it on the plan. I expect the plan is not going to change at all really after it's finished. But the code obviously of the Rust plugin is going to change often. So
Okay.
You can imagine triggering on both though, for sure. But I think it's really a question of like, what events do you want to have A, publish a new package, and B, deploy it to stable, right? So I could imagine like deploying it to stable means a new commit's landed on master of Marshall's Rust plugin. Okay, so basically it built the thing. So now we'll just go back to some of these things open here. Just close these up. All right, so here I am on the prod node again. It's port 3082, and now if I upload this, so you can see this is 2017 ending in 408. So if I go back to here,
and that should be on the unstable.
Right. Yeah. So there should be a new unstable here, 3408, right?
Mm-hmm.
And now you can see
the production node should still be running.
Should still be the same. Yep.
Yeah.
And now if I promote it, promote, and then since now it's basically this version that we want to promote, we do that and we say stable. So now promoted it.
And now the production node should have filled that old one.
Yeah, I think there's like a poll interval, so it's probably like some 30-second type delay.
So it should still be on the old one now, probably.
Yeah. So what was it? 3082.
And so is this polling the depot?
Yes.
Okay, so it polls the depot to check if anything is updated. If it does, it'll take down the current one and bring up download the new package, install it, and then bring up the service name.
Yes, I've seen it do it. So one thing I'm not too stoked about with
we know that it works.
is the logging kind of sucks. Like, I'm pretty sure this started up with the right thing. Let me just make sure it's set to strategy at once. I don't know if I can see that here. Shit, it's not doing it. Weird. The only thing I think of is maybe let me just see this first, actually.
Yeah, see if the package is
Yeah. I was like messing around with this stuff, so maybe yeah, it's not even picking it up. The service might not be started properly.
But should that matter though? Because it should.
If the strategy flag was not flipped,
then it's not going to be checking.
Yeah, I was like stopping and starting the service on this node, so it may. I have a feeling that maybe that's what's going on. In fact, I can show you if I go to localhost. I think it's 9631, 9638. What was that? Oh, sorry, it's firewall. Or it's bound to the local IP. 322.37. Go to census. This is Habitat, basically.
Mm-hmm.
So, where's all that crap? Where's all that? Must be the key or something. Jeez, that's rough.
I don't know where.
I'm just looking to see if if I can see what startup strategy it has. I think if I do this actually. If I do GQ, this, yeah. I have a feeling it's running not in that room. Alright, well, it should work. Yeah, I never ran, so. Oh well, in theory it should work, but that's the workflow at least. I have seen it do it, so my guess is I just started it wrong. Cool. I think that's probably about it.
And that only fucked up because probably because you were mainly messing with the node, which you shouldn't have. In reality, shouldn't be doing.
Yeah, let me just see if I have it in my history still. Oh, you know what? I don't know. It's not here. Oh wait, it would be here. Start. Yep, there it is. See, so I started it without the strategy.
Okay.
Yeah. Okay. Yeah. So basically, to show you that, this is just because I was like hacking on stuff, but yeah, in theory, like we should never be hacking on stuff once we're happy with the setup.
So if you kill that node, it'll bring up a new one.
Right. So if I do this,
and actually start it with the right strategy, and then pull in the.
Yeah. So.
What did you manually start? You manually started.
Janus.
I was debugging like a
with
thing.
the wrong strategy. So like he started the Janus service with the wrong package or with the wrong strategy, so then it doesn't check for new packages.
Yeah. So.
Could you have not manually killed that service and then started again with the right, or is that like?
Could I do it? Yeah, I could do that actually. Oh, I could have done it. Yeah, if I did that, I should have pulled it down. Yeah.
Yeah, you could have manually killed it and then restarted the service, right?
But it's just easier to destroy it.
Yeah.
Almost is, so that's nice.
Yep. So anyway, there's still a lot to be done on the Reticulum side, probably just in terms of getting the ALB working and all that stuff. We have a DNS for Reticulum IO. I think my plan actually is to all the internet-facing nodes. I think we should have a human-readable name for them.
Mm-hmm.
So I'm not really sure exactly what to do. Like, open to suggestions on generating. Let me just hit stop.